All right, so the equilibrant is going to be the third force that we would add to these two forces that would add to zero, a force that would put this situation into equilibrium. Clearly, these two forces are not going to add to zero. They're going to have a net force in this direction. Okay, so I'm going to show you how to do this using force equilibrium equations. So the first thing I'm going to do is I'm going to draw a picture of the components of B and A. Okay, so to do that, I just draw. And since they labeled that 31-degree angle there, I like to draw a triangle around that, right? Now, of course, the components make a right triangle. The opposite side here I can find by, that's 31 degrees, right? So this side here is, that's just 23 times the sine of 31, right? Notice that that guy is to the left because it's there, right? And then this component right here, the x component. Okay, so this is b in the y direction, right? And then in the x direction, we've got 23 cosine of 31. Okay, and that would be in the positive y direction, right? So this is in the x direction. This guy's in the y direction, okay? And then let's draw the components of, let's try red, okay? Let's draw the components of A, right? So the components of A look like this. Like that, right? And this component is, what is it? It's 17 times, and then it's opposite that angle, so it's going to be sine of 42. And that's going to be in the positive x direction, right? And then this component here, that guy is, what is it? That's 17 positive 17 cosine 42, and that's going to be in the y direction. Okay. So remember that if you've got a triangle, say you've got a little triangle like this, remember that, I'm just doing SOHCAHTOA here, right? Okay, this is the, if we know that angle, right, this is the side opposite. So if that's the hypotenuse, that's h sine theta, this is h cosine theta, right? Because the one that's cozy with the angle is the cosine. Okay, we really didn't need that, did we? Okay. So let's go back to blue pen land here, right? So now all I have to do is just set up a equilibrium equation, okay? So, or two equilibrium equations, right? So in the x direction, we've got negative 23 sine 31 plus 17 sine 42. I'm taking all the things that are in the x direction here, right? Okay, and then plus whatever this new equilibrium is, I'll just call it E in the x direction, right, is 0, right? So whatever the equilibrium, whatever its x component is, right, all the x components have to add to 0, so we can set that up, right? And this has only one unknown, so we can solve that, right? Let's do some maths. Okay, so let's see. The opposite of, and basically to find this, I'm just going to take all of this, find the opposite of it. So I'm going opposite left parenthesis, negative 23 times sine of 31. Make sure you are in degrees, plus 17 times sine of 42. All right. And that's just not very much, okay? E in the x direction ends up being something like positive 0.4765. I'm going to store that in x just for fun. If I can find x. Oh, there it is. Okay, and now let's set up our y expression, right? In the y direction, we've got positive 23 cosine 31, and we've got this y component there, right? So positive 17 cosine 42, and then plus E in the y direction, that's got to add to 0. Well, these are clearly positive components. If they don't come out positive, you're in radians, by the way. Okay, those are clearly positive components, so this has to turn out negative, right? So I'm just going to, basically what I do is everything that's not EY, I just do that and negate it, right? So opposite of left parenthesis, 23 cos 31 plus 17 cos 42. And I get negative 32.3. I'm going to store that in y just for kicks, right? And now I got to draw a picture of this guy, right? So this thing's going to look like this. And we're supposed to draw it on here. So let's just draw over. And I'm exaggerating that over just because I want to make a, there we go, down, right? So over, this is to the right. This guy's down, right? Because it's negative, right? And then, oh, that's pretty good for a trying line like that, right? For a diagonal line. So this angle right here, okay, that theta is tan minus 1 of the opposite side, which is what, 32.348 divided by 0.47065. Okay, so second tan, I'm going to go alpha y divided by alpha x. I always just find the angle with what the, I don't know, I guess I find the angle with the x-axis is what I tend to do. 89.2 degrees. Right. Okay. So what does that mean? I guess that would mean that this angle here is 0.8 degrees, right? So we got the angle correct. Okay, and then the magnitude of it, the hypotenuse, this guy here, that guy is equal to the square root of 32.348 squared plus 0.47065 squared. Now, you know, this side's so short that essentially the answer will be this, right? But let's just do it anyway. So square root of left parenthesis alpha x squared plus alpha y squared. I stored this in x and that in y, so I can just do that. I get 32.35, so it'd actually be 32.4. Not quite the length of this side. Okay. So our answer is that this is 32.4 newtons. And then if you labeled this 89.2 degrees, that's just fine. All you have to do is just draw a picture of the equilibrant. Okay? You're all set.